Okay, I think let's get going. The plan here today is that we have an hour session, of which the first 45 minutes will be the actual webinar, the presentation. And then there will be 15 minutes for questions and answers. So, as it is a webinar, the process or the mechanism will be that you can ask your questions in the chat, and we will find the time and possibility to answer that. I think we can. Oh yeah, the topic for today is South Africa's first digital water twin, a blueprint for progress. And this is a very interesting presentation, at least from my perspective, in that it is a cooperation between three parties, between George Municipality, and represented here by Tahseen Raymond. She was a senior engineer at George Municipality, currently with MISA, and as technology, or she changes her position as fast as technology. So difficult to keep hold. But a week ago, she was still with George. And then myself, Alex Sinske from GLS Consulting. I'm heading the technology side of things at GLS. And I'll talk a bit later about GLS itself. And then we have David Montero. He is from Qatium, Director of Customer Success. And he will be doing quite a few of the interesting technological presentations later. So let's start off with some housekeeping. As I've said, the chat is on the right-hand side. Then there's also, should you need or be interested in a demo or booking a demo, there is a button at the center bottom of the screen, which will allow you to book a future demo of the Qatium solution with myself and or David. I think we are ready to move on. So let's get going on this very interesting presentation. David, if you can move to the next slide.
Thank you, Alex. Hi everyone. Nice to see that we've got people from all corners of the world. I see like some people from South Africa, obviously, but also all the way to Uruguay. So looking forward to talk to everyone after this presentation. So let me give you a little bit of context, right? So as to what Qatium is, where it comes from, right? So Qatium comes from that idea that the future is here. It's just not evenly distributed, right? So we're talking here about the first South African digital twin. So it's really appropriate, right? So digital twins have been around for a little bit right now. We've seen people in Europe, people in the US, Singapore, right, leading almost all of the utilities, being really at the forefront of technologies. So the technology is here, right? It's just not evenly distributed. And so on that premise, basically, Qatium tried to expand on that and think about what are the barriers to the water sector. And so one of the things was thinking about water technology not being accessible, the utility knowledge itself being siloed, right? So it's often in the heads of people, not in the tools. And so it makes the utility itself less resilient, right? So if something happens to that engineer, to that consultant, if they change consultants, then that knowledge is lost, right? It's very hard to get it back, to transmit it to potentially the next generation of operators, engineers, IT people, whoever it might be, stakeholders in that utility, right? And so last but not least is operators lack resources, right? So operators are always firefighting, so to speak, right? So going from one emergency to another when it's not an emergency, it's making sure that the network is really resilient, that the network is still providing water safely in the right quantities to the people that need it, people that ask for it by opening their tap, right? And so all those combines was basically an indication for us that our lovely sector, which is the water industry, right, isn't prepared for the current and future water challenges, whether we think about shortages, whether we think about PFAs, whatever we think about water quality, generally speaking, whenever we think about climate change, and so on and so forth, right? This is just the tip of the iceberg. And so, how do we go about it, right? And so, one of our first premise is that potentially having a digital twin, right? Having something, some sort of replica inside on a digital environment where we can understand what is happening, right? And so when we think about digital twin, we actually have different levels of digital twin, right? Something that if you talk to the oldest engineers in the room, they say, oh well, we didn't coin the word digital twin, but we were using GIS. We had maps. We were the first one who digitized it, and so on. So first step of the digital twin for us was really that data canvas, right? Thinking about where are my assets, what are the assets that I do have in the ground, and actually making sure that all that information is somewhere else than in someone's mind, right? So again, thinking about that resilience of the organization, of the network. The second level was really thinking about, okay, how can we make that real time, right? So combine the information from the GIS, from the ground, from the field, sorry, but also sensors, about live data, to making sure that not only we have some GIS information, not only we have a hydraulic model, and we can model how the water is moving across the network, we can do that in real time. We can understand what is happening, when it's happening, potentially try to think about predicting and so on, right? So in that, now we go into more the digital twin space where we have some custom setup. We're connecting with different other operational tools, right? So we're talking about workflow, potentially moving from digitizing to digitalizing, right? So making that transition where we're thinking about how can we improve our business, but also operational workflows, our operations from an operator perspective, from an engineer, whatever it may be. How can we make the most of the information that we already have, trying to again break down silos and really focus on different use cases? How can we improve all that? So it's really a custom setup, right? So going through that through some operational tools for decision making, because ultimately it's great. We know where the assets are, we know what's happening right now, we know what's happening in the past, but really what we want to understand and do is take a decision for right now, take a decision for the future, for answering the issues of right now and preparing for the futures of tomorrow. So which is essentially building resilience, right? And so we like to think that when we think about technology, there's a lot of AI word going around, machine learning that's been around also for a little while now. So using all that goodness, all that technology that is out there that potentially a lot of you are using in your day-to-day, using ChatGPT, Gemini, or whatever flavor of AI models you have, whether it's DeepSeek, whether it's Grok, whether it is using it for coding in cloud and so on and so forth, right? I'm not going to enumerate all of them, but using that in combination as the next step of your digital twin, which we like to think it as a water intelligence platform. And so beyond allowing you to test around and understanding what is happening, being able to make decision, being able to predict, being able to optimize those network performance, those operations, and combine all larger streams of information, right? Not only GIS, not only hydraulic modeling, not only live data, not only historical data, and not only in a customized way, but also potentially combining that and finding correlation, making better prediction, making better optimization, right? And so thinking about all that and that journey, right? So going from collecting data in the field and putting it in a database, whether it's through GIS and so on, the idea, or to all the way down to AI and improving your your operations, this needs to have a purpose, right? So I talked about digitizing. We're moving into from digital to digitalization, digitization to digitalization, right, of your utility, right? So thinking about your processes, your resilience, your efficiency. So those are the key things that we want to be able to improve throughout your organization, right? So not only thinking about, okay, what does an operator do, but actually as a whole, right? So what are the kind of reports that an operator needs to do, that a utility needs to do to its regulator? How can we better manage that resources, right? So minimizing non-revenue water, optimizing those cost of energy, thinking about potentially weather issues that are coming up, whether you're in a region where there's a lot of typhoons, hurricanes, or whether you have a lot of droughts, so one end of the stick or the other. And so making sure that as a whole we improve this operations of that utility, to improve that workload, reduce that workload, making things automated, and ultimately improve satisfaction of both your customers, so people who are actually going to be drinking your water, but also your members, right? So all your employees, everyone on your team can now have access to that information, make decision, understand context, right? So bringing all those series of information in a single platform, which I'll be doing a short demo after. And so we think about that, and how does that it actually apply, right? So I talked a lot about the concept, a little about what we're trying to solve, all about the things that we're solving, and we're going to discuss a lot about it after in a couple of minutes. And so how does that apply genuinely in your day to day, right? You're an operator, or your operators on your team, or your organization, or your engineers, how are they going to actually feel the difference, right? So by using a digital twin, like Qatium. So we think about it as digital insight, physical impacts, right? Because again, ultimately what we want to do is make decision, carry out decision uh, directly in the field, right? When it's happening, before it's happening, planning, and so on. So first, understand, right? So you see that person right now on the screen is on their laptop. It could be a tablet, but what they're seeing is the screen that is at the back, and understand what is happening directly in the map. Very visual, understand what's happening. The next step would be to simulate, right? So we're in a digital twin environment, so we can test out scenarios, right? We'll be able to do hydraulic simulations, and be able to understand what would be the consequences, what would be the impact, whether beneficial or negative, on the network, on our customers, on our team, of whatever operation we're carrying out. By doing that, we're able to optimize that, right? We have visibility into the impact. We can choose who are we going to impact, whether it's better to impact a hospital or a school. And this is going probably too far away in the ethics side, but it's really trying to understand and plan from it, right? So, okay, we're going to have to change that pipe. We're going to be impacting a hospital. Well, we need to have a plan in place, right? So, and therefore, it's mitigating all those conditions and that emergency that is coming up. And the last, which is like prioritize, right? So we have a bunch of actions that we could take. So let's do what matters most first, right? So we are optimizing the network as a whole, not only our operations, to understand where is the area where we have the most non-revenue water, for example, the highest level of leakage, and that's where we're going to send our team. They're going to have much more easiness in finding that leakage, because it's going to be an area where there's potentially high leakage, for example. And also they have going to have more gratification, right? So the having a job well done, so to speak, right? So being able to understand and to actually feel valuable towards your community, towards your organization. So also thinking about a utility as an organization, right? So how do I retain talent? How do I onboard and make technology serve people rather than people at the service of technology, right? And so with all that said, I'm going to pass out the mic. I've been monologuing for long enough. I see that there have been some more people joining, and it's been exciting. And so now we're going to talk a little bit more about that case of George Municipality in South Africa. And I'm giving the mic to Tahseen.
Thanks, David, and greetings to all the participants. So just a little bit of background about George Municipality. Our population size is approximately 295,000 people. The water network is about 1,000 kilometers, split across one large city or one large water system, and then 2 or 3 smaller networks. We have 5 primary reservoirs, about 68 pumps, and 2 to 3 water abstraction sources. And George Municipality wants to become a smart city. And my work is specifically focused on becoming a water smart city. So we have a comprehensive 5-year plan, and we're looking at optimizing our workflows and the way we operate the water network using modern technology to enhance quality of life for all residents and to ensure that we do deliver our services in as cost-effective a manner as possible. Bearing in mind that funding or investing in something like the digital twin is more effective than more boots on the ground, because you are able to then prioritize your actions, like as David pointed out earlier. So the plan we have outlines a new approach to governance, infrastructure development, and service delivery, with a strong emphasis on innovation, digital inclusion, and data-driven decision-making.
David, can you switch to the next slide, please?
So some of our challenges was, firstly, before we went over to the digital twin, we started out with a digital map, I think is the best description. And that digital map was available to a few people, and then other people were working on physical hard copy maps. So there was a lot of guesswork with regards to visibility in the network, what was happening in terms of flows and pressure. And as a result, there was a poor understanding of network operations. And our focus has always been to increase the efficiency of the water network and reduce our non-revenue water. And again, it comes back down to locating where leaks are and then resolving those leaks as swiftly as possible so that they don't worsen into full-on pipe bursts with a long duration of water outages. The next.
David. So, GLS has been involved with George Municipality for quite a while. Just a bit of backgrounds on us for those who don't know us, but probably most of you know. But we've been in existence for 35 years. We have our main head office in Stellenbosch near Cape Town, and we have some satellite offices throughout South Africa now. We have quite an expertise in the full life cycle of water, sewer, stormwater, electricity, and also now optical fiber networks. And our mission is to provide clients with the tools and expertise to optimize infrastructure, improve service delivery, and build sustainable communities. So with our involvement at George Municipality, we were fortunate to find the opportunity to pilot the first digital water network twin in Southern Africa, as we believe it is unique and new. And but that's on a basis of us having done a lot of work before in the analysis and master planning of George's water and sewer networks. And we were fortunate that it came about that was Qatium international solution provider, together with George Innovation Strategy and the drive for smart city, that we could start with this pilot. David, if you could go to the next slide. So what we then started off is we already had quite good existing hydraulic models of the water network of George Municipality. We develop our own software, desktop-based, and for hydraulic analysis, we use Watiso, which is an EPANet-based hydraulic analysis tool. So the process started off by obviously taking our existing peak hour steady state model, which is designed to analyze the worst day of the year in a water network, but to turn that into an operational model, so that not only are we looking at a sort of worst case state, but we need to look at more the typical or average state of the model on a typical day. And that also involves turning that existing steady state model into a extended period or time simulation model, which classically is 168 hours or 1 week long, for the purpose of planning the worst week of water demand in a town or city. So we did that, which was quite an extensive process if that extended period time simulation model does not exist, because it takes account what happens on a daily basis or weekly basis in a model. How do reservoir levels change? When do pumps switch on and off? And when are valves switched on and off? And what other operational rules apply? So from that 168 hours, my colleague Johan managed to process it and reduce it to a typical 24-hour, typical day model, which then was further calibrated using the real-time data that we had available to try and mimic the information as good as possible for that typical day. And that then allowed us to export the model to the EPANet industry standard format, and together with auxiliary data such as GIS data with regards to the DMA, which is the district metering area zones and polygons, import that into Qatium. And I'm going to give over to David now to take us through the typical steps, what happens next.
Brilliant. Thank you very much. So that, as Alex mentioned, that was the case for George that he just explained, right? And so we were quite lucky that there was also GLS on board, and that they had all this extensive not only experience, but experience also with that utility, right? And you might think that I don't have a hydraulic model, I'm not using any of that. I'm still using GIS. I do have some live data, but maybe it's not enough, and so on and so forth. So let me walk you through very quickly how does it work on Qatium, right? And how we make that happen, and how do we build a digital twin, right? So very quickly on Qatium, the idea is to drag and drop your information in the interface. Where is the interface? The interface is a browser-based, because we're a cloud application, right? So there's no installation required. Qatium natively understands GIS data, AMI, SCADA, INPs, like Alex mentioned, right? So hydraulic models, and it will combine all this information in order to build a running model, right? So it's a half-calibrated model, like I like to say it, and so it does require a little bit of manipulation. But what we're doing is definitely augmenting your information by cleaning it through some AI. If your GIS is not perfect, that is okay. We're inferring the network connections, and we're creating that model that is functioning, that is ready to use inside Qatium, right? So you'd have improve your information just by dragging and dropping your data inside Qatium. But as Alex said, right, so there is some work in calibration if we are going from scratch to go into Qatium, but we're trying to make that as frictionless, as intuitive as possible. So you can get all the benefits of Qatium, right? So what I was talking about earlier, whether it's operational scenarios, network optimization, asset management, and so on. And we do all that so in a cloud-based browser environment, which is secure and easy to use, right? So nothing to install, just a drag and drop and managing those files like this. I'll leave now the rest of the story of George and what is the next step to continue on. Oops, sorry. Here we
Thanks, David.
go with Alex.
Yeah, so the next step is to try and connect real-time data. So we have our hydraulic model, and it's already extended to a 24-hour operational model. But the nice thing, or the ideal thing of a digital twin, is that it should be informed and be updated by real live data. So what we managed to do is to live link 130 online bulk meters to create an operational troubleshooting and asset verification tool. That involved looking at bulk flow, pressure, and level sensors that typically measure the data on an hourly basis. We soon realized this data wasn't available in the cloud already, as in a perfect world. So we had to write some software to facilitate cloud-to-cloud message queuing and allowing the data from the telemetry provider to flow straight into Qatium's database. And that's through our own application that we developed called GLS Historian, which filters the data a bit, tracks bad data, and at least provides some quality of information flowing, and provides us with a database, historic database of actual metering data. Then this allowed us to develop the first version of the digital network twin in Qatium, where the live data is then connected with the model. And effectively, you have a merged intelligent model that is updated by the live data where it exists. And obviously, where the live data is not available, it is simulated. And David can maybe talk about that also just now. But it is then providing an intelligent environment where you can do further activities. I think the next slide takes us just to George Municipality. David?
I'll come in. Yeah. Okay, so what you see on the screen is the Qatium model for George. Technically, it's the George and Wilderness Water System. It's the largest network. And if you look from the top center, you will see these quite distinct purple lines. Those are our largest lines, largest bulk lines, 1,000 diameter. On the left is the western, and on the right is the eastern. And between those two, they feed the majority of George. The very nice thing about the Qatium model is I could use it to communicate to external engineers how the water network actually works, which influences their design in any new infrastructure.
David, if you want to take us now through some digital twin use cases.
Brilliant. Yes, absolutely. So so as Tahseen and Alex mentioned, a lot of value in just having it, right? So understanding what is happening, being able to share with stakeholders who they are, however their level of literacy or context about your utility, your networks. It makes it very easy to exchange about potentially an issue or an upgrade or whatever it may be. But beyond that, right? So think about digital twin. So we have basically essentially a replica of your network behaving in the same way that your real network is inside a digital environment. So that is easy to use and so on. So what we're going to be able to do is virtually any operation that you could carry out in your network. So from water main shutdown, flushing, managing system pressures, trying to pinpoint the optimal pressure sensor location, handle any kind of like fluctuation in demand, ensure fire flow, check on hydrant capacity, identify energy inefficiencies, across the network, right? So is there any bottleneck inside the network? Can we actually be more proactive in removing those bottlenecks that in the future, from a planning perspective, is going to be critical? So minimizing non-revenue water, monitoring water quality, right? So being able to see where are your dark spots on the network. And so without any further ado, I'm actually going to show you how it looks like inside Qatium. I'll be also conscious of time because we have a lot more to show you and to tell you, but we wanted to show you how it looks like inside Qatium and what you can do and see what is the art of the possible. So here we're inside Qatium, that map that you could see in a couple of screenshots before, and that Tahseen mentioned, that George was seeing and explaining to other stakeholders. So here what you can see is the animation flows, right? So this is literally how the water move throughout the network. Very easy to understand and very relatable. Pressures, for example, right? So at an aggregated level, whether it's through those hexagons and understanding what is the impact of whatever is happening in the network, right? So real-time data, but also historical and so on, but also scenarios, right? So you're changing the status of a valve, and you'll be able to see the impact on the pressure and focus potentially on some of the pressures across the network, right? So low pressures across the network, how are those low pressures being impacted? Is there new points in the network that are getting low pressures that I didn't anticipate? And so on and so forth. Locating where is the lowest pressure in my network. So all those questions very easily answerable, right? But you can see also that we have a little bit of monitoring happening right now on what I'm sharing. So right at the bottom, so we have some warnings going on. So if I go to that one of the times with those warnings, I can see that they're flashing up on the screen. So I can just click on them and see what is happening. Hope everyone is able to read my screen. If not, just like pop a message inside the chat, and I'll try to zoom in a little bit. Otherwise, you can see that we have information about any kind of asset, right? So pressure, water age, consumption, those are all the variables. If you were a pipe, you'd be able to see also pipe material, installation date, diameter, and so on. In this case, we also have the pressure sensor that is coming through. So it's going to be that blue line that turns orange when going below the threshold, and also the threshold line, but also the simulation that is right here. So being able to also compare that information, right? So very quickly understand what is the deviation inside the network, where are things happening, even if you don't have a threshold defined inside the network. So being able to understand what is happening at a global level and also at a micro level. If we think about operations, right? So I've been talking about operations, and I'm just going to show you one today for the demo. But the idea is that you can do flushing, like I mentioned, right? So you can do flushing, you can change any kind of like setting on a PRV and so on. But what I'm going to show you today is more of a workflow, right? So we're thinking about shutdowns. So how do we do shutdowns inside Qatium? One click on the pipe, one click on the plugin to close that or isolate that pipe. what is Qatium doing? Is tracing down to those valves. Once it's traced to those valves that are closer to minimize the impact on the isolated customers, is going to close them, right? So we've put them in red to show them that they're closed. We can review which valve are that. If reality of the field, one of the valves are not operable, we can do that in Qatium. Every time I'm making a change, Qatium is relaunching that simulation. We can see here that in that case, Qatium has expanded that simulation and was able to tell you that here are the next valve that I need to operate, as well as what is the impacted area, right? So we have here our impacted customers, in red the one that are within that bounded area, or in yellow the one that are not, right? So the one that are not, it means that here we have some valves that are operable, that we can reopen and provide water back to those customers. And by providing back those water, Qatium is going to update again that simulation. So every time running the simulation, every time that happens. And so we can see that we're only impacted 3 customer points, right? So within that area, right, those 3 red dots. We can also check whether we have any critical sites on the map, right? So I talked a little bit about looking at what is the impact. What is the impact on the network? What is the impact on specific customers, right? So here we have a hospital and we have a school that's in the area. So we probably want to take extra caution or implement a plan that's already been discussed and on how to notify, how to manage that shutdown. And last but not least, we will obviously want to check on the pressures, right? So making sure that the people that were impacted and that now we've provided back water to them are actually getting water, right? So, are not only getting water, but are getting sufficient pressure, because if they're getting 1 or 2 meters of pressure, this is probably equivalent to not getting any pressure and not getting any water. In this case, we can see that people are getting sufficient pressure, right? So all the colors are well above this pink and purple area colors. So I see that when I select those ranges of pressure, I'm filtering throughout those, and only 3 customer points, so the one that are within that isolation area, are going to be impacted here. And so all is good, and we can go ahead and either download that as a report, PDF, for people to carry out this work order, to carry out those notifications, or we can potentially send that to our CIS system, so customer information system, or to our notification directly, whether it's the fire department for all the hydrants that are going to be impacted, or if it's directly the customers themselves through the application that they might have, or WhatsApp, or email, or fill in the blanks here, whatever method of notification that you have for your customers, even if it's just knocking on doors. So Qatium will be able to provide you with the addresses of the location to go and all those customers. That is it for the demo, because I've been rambling a little bit along. I hope that this is super useful to everyone to get some context about Qatium. How does that work, and what kind of scenario we can do. Just giving you more information about the other core benefits, right? So that we would have for George and for any utilities on Qatium is going to be really about resource optimization, right? So thinking about how can we improve that non-revenue water, right? So drought is happening to everyone at some point. I feel like there's no places on earth that is safe now, right? So we've seen droughts happening longer than before in places that didn't used to have any. So I'm subject to it. I'm based in Barcelona. We've been in droughts for 2 years. Sorry. So definitely relate to that. Operational efficiency, right? So saving that easiness that you could see me clicking on a couple of buttons and finding insights and being able to just bounce back from one scenario to another, optimizing it within a couple of clicks. All this that usually takes months, right? Or at least days or weeks to get to an optimized scenario. And when we think about people that are not familiar with a network, right? So potentially also shortening that onboarding, and ultimately network resilience, right? So we want to be prepared for emergency. We want to avoid any kind of complications, because in complications means more resources dedicated to it, more resources, more cost, right? So, and ultimately a higher bill to pay, right? For us and for our customers ultimately, right? So we want to make water safe and affordable, right? And now I'm going to stop rambling and give the mic to Tahseen to tell us a little bit more about George.
Sure. So, in terms of where George Municipality started, we had the digital map which GLS maintained, and we also had our telemetry system, which is where the bulk of the AMI data comes from. And we also have our smart meter project, which is currently rolling out. And all of those are advanced meter instrumentations, and they fed into the digital twin. So they weren't specifically designed to feed into Qatium, but the team was able to pull everything together into a coherent model. And in the process, they found that for the purposes of the digital twin, we would need to recalibrate or otherwise change the communication link from the sensor to the digital twin. And what I can emphasize is that as an organization, we have to think of an end goal and then work towards it. And George Municipality has been very fortunate to have supportive service providers who are well versed in all of these technologies and can really transfer their knowledge back to the organization. Ideally, it would all be in house at some point, but no organization is perfectly positioned to just take it on. So it's very important to, partner with the right people, partner with other organizations that have already been through the journey and can bring their experience to the table. The All three systems are a work in progress. The telemetry system is always being refined. There's always little tweaks that are being done here and there. The water network is always having sensors added to it, whether it's pressure or flow. We'd love to do quality sensors as well, but the focus is more on pressure and flow. The digital map and Qatium, we are always refining it as well. As I say, no network is perfect, and there's a lot of operational knowledge that's locked up in the heads of field workers, some engineers, some technicians who work with the network. They know there's a valve here, but it's not on the network yet. It's not on the digital network, sorry. It might be on a sketch in someone's notebook. And, a key part of transitioning to a digital twin is to get the buy-in of those staff, especially long-term staff members who've potentially worked with the water network for decades, to get them on board and to share their knowledge, to feed it back into the digital twin, into a single platform that then everybody can use and everybody can learn from. Okay, back to you.
Yep, David. So some key challenges that we've picked up, and it might be typical for many other cities in Southern Africa, is that you have to end up with an operational model. And typically operational or time simulation calibrated models are not generally done or not generally updated. So there was quite a bit of effort from our side, but and then key involvement of the municipality and the operational teams to understand the day-to-day operational rules and also where zonal isolation actually happens. the bulk meter data reliability. Many of the bulk meters may produce unreliable data unless they've been previously audited and corrected. And so through Qatium, we've identified that although we had 130 meters, about 30% of them were giving inconsistent data and had to be corrected. When it comes to the AMI data, that is the end user data, we also discovered that it's not a perfect world. The data isn't flowing in at a high frequency. At best, at the moment, it's once per day. And so we are at the moment looking at a plugin to develop to mitigate that requirement so that we can do water balances in zones with a mixture of data from monthly data reading in combination with more accurate ones where available. And then I've mentioned this before, the vendor integration gaps that most local bulk and AMI, or probably many of the vendors, lack cloud-based APIs. And so there's some effort needed to develop that or to open it up so that communication cloud to cloud is possible to Qatium. Going to the next slide, I want to just finalize the 3 steps that we've been going through. So we built the operational model together, and it's now in the process of updating it, improving it through feedback from online metering data and improved metering rules or operational rules. Then the real-time network is also being updated, and it's now possible to do not just the initial work analysis, but also emergency planning and situation awareness. And we are looking at developing customizations in Qatium for that purpose. And finally, Tahseen, you might want to comment on the improvements regarding the DMA and the zoning.
Yeah, so once we had the Qatium model up and running, one of the things I picked up was that there's a massive lack of data for our CBD area. And really, the CBD is the economic heart of the city, and it employs a lot of people who would be severely impacted if they didn't have water. So before I left, one of the drivers was to improve sensors in that area, increase the AMI data we get out of it. And the ultrasonic meters mentioned on the screen are our smart meters, domestic smart meters, which would feed data back into the Qatium model. One of the things that I was also working on was getting a better version of those ultrasonic meters, which could provide upstream leak detection as well. And feeding that into the digital twin would have also improved the alerts, as well as picking up if there was any zone cross flows.
Thank you, Tahseen. Yeah, I think at this point we probably want to pause and see if there are questions. On this slide, you will see our email addresses and related websites where you can find more information on the various solutions and products. But I want to just emphasize that GLS is, where possible and it's feasible, available to assist municipalities, utilities, and even other entities like maybe mines to help them build a digital twin solution using Qatium. But let's just check for questions from the audience. Anything coming? Anybody still listening? No, just joking.
But everyone fell asleep. Hopefully not. Hopefully not. I still see a lot of people still going strong.
But maybe while we're waiting for some questions, David, so now we found it definitely the algorithms that Qatium is using to build this digital twin, to maintain it by combining live data with model data and updating the model on the fly as new data arrives, very valuable An example would be a closed DMA, which for which you have the inflow and the outflow bulk meters. So then you know what is actually flowing in or potentially out of the DMA. And for that specific time step, you can then control and say that would be the total demand in that area must equate what is actually measured on its boundary minus some losses. And that is then set as a value for the nodes in that specific DMA. And similar for at the beginning of a day, the water level in your reservoirs is set as it is actually measured from the telemetry data. And it's not just some maximum or minimum or average day, so average value from the reservoir. So there's an automatic calibration happening with the live data. And where you do not have the information, you can then derive, for example, what is now the pressure. And that is calculated from your hydraulic model at a critical point in, for example, the DMA. So that makes the digital twin very valuable, but it's also only as good as your data. So it's important to have the model as well as the source data as accurate as possible and continue updating. There are no questions. Maybe David, you can take us through the last slide and yeah, maybe conclude unless you have something else to share.
I see a couple of questions.
Yes.
So one is so I see them and I see both. There are some in the chat, some in the Q&A. So feel free to use the Q&As also. Makes it easier for us, but we'll also try to address everything knowing time. If we don't answer any question, we'll reply them by email to you. No worries. So the first question is, what sensor provider does George use, and which would you recommend? Right. So I think it's in relation to you mentioning cloud-based and potentially having to do some extra work when it's not. So if you can share anything around those comments.
Yeah, so we used a standard provider in Southern Africa for which the data is typically stored locally in a SQL database and not in a cloud platform. And that's often the case in many of these providers, that the cloud platform is either not available yet, or it's an extra cost, or the client hasn't purchased it. But as a minimum, the data is available and arrives in a local database. So we had to develop functionality to get the data from the local database on a continuous basis to our historian and onwards to Qatium. Yeah, so, and there are various providers. So one would be for the bulk meter, and there would be typically a different one for the AMI metering infrastructure.
Brilliant.
For George, we had a combined for George. The service provider was Spectrum, and our bulk meters were SAFMAG, I believe, magnetic flow meters. I can't quite recall offhand the pressure sensors we used, but we've had good success with both the service provider as well as the sensors. I think I can just recommend that if any organization is not starting like George with a telemetry system in place already, where they should start is actually just getting level sensors on the reservoirs. Yeah, and I think that would assist greatly in terms of alerts as to if there's a sudden drop, you'd be able to figure out quickly that something's wrong on your bulk lines.
Yeah, no, absolutely. I'd second that. I think that the most important sensors are going to be levels of tanks, because from there we can infer inflows and outflows from those tanks, and from there we can infer demand. And so from there, it's kind of like there's a lot of inference to do potentially, but Qatium takes care of all that. So yeah, definitely, I think the single most important sensor out there. Although obviously, as we want to increase in capabilities and accuracy, getting some other additional sensors is also critical. Second question, and we only have 3 minutes left before the gong, is does Qatium have any active existing digital twin models other than George? So I guess this one is for me. So we do have, so Qatium is actually present on all continents. So that's quite exciting. So from, I think the most eastern is going to be Tauranga in New Zealand, and the most western one is probably going to be some utilities in California, if my geography is about right, or Mexico. But it's going to be, California, so Roland Heights and so on. So yeah, absolutely. We also I want to say this probably similar time zone. We have a bunch in Europe. Anglian Water, for example, is a name that comes to mind, and I know that there are some ties between South Africa and utilities and English ones. Or yeah. If you're keen, happy to put you in contact with any of our customers to see what they're doing and so on. Next and last question I think that we'll have time to do is, how is the process of converting 24-hour model to a Qatium model like? Is it highly advanced, i.e. requires coding, etc.?
So I can maybe comment. Thank you, Mariana from Namibia. So I think if you actually do have a calibrated 24-hour model, which represents your typical day, then it's very easy. That is sort of the real input that you need, and that goes straight into Qatium via the EPANet format. And but to get to that state, if you haven't built that yet, and it's not calibrated and it represents reality, there's a bit of work, and it's a team effort then between the modelers and the operational team to understand how it operates on a daily basis.
Awesome. Thank you, Alex. And it gives us exactly 1 minute to finish on a high. I promised you that we were going to go high and higher on this presentation. So the idea here is what to do now, right? So you've got a lot of information in the span of 59 minutes, and the last minute is about like, okay, what do I do now? What are the next steps if I'm interested in knowing more and testing and so on? So we have this this process of proof of value here at Qatium, which the idea is to work with the utility and the partner and whoever needs to be involved to define a project, right? So define a scope, define a success criteria, meaning, okay, we're going to work towards achieving X and Y goals with Qatium, confirm what data is available, who is going to be involved, the stakeholders and the users, the people who are going to be using the platform. And so once we do that and we package that little project with a nice little bow, which is the kickoff, then we execute on it, right? So we prepare the environment and make you a super user of Qatium for a month. And the idea is that with that execution, we actually have validation of your success criteria, whether regardless of the position that you have in your organization, you'll be able to defend your position as to why was this a success, why was this not a success potentially, what worked, what didn't, what learnings did we have, what do we need to do better, what do we need to work more, what data potentially we want to also acquire to augment even more the value of Qatium in the digital twin. And so after all that is done, well, then is like we work on a business case, a discussion, right? That validation that we're getting after that execution, making sure that we help you build that proposal internally, and that you can convince whoever needs convincing, or create the RFP that you need creating. That you have the tools right with you to be able to to go to the next step, which is the implementation of the digital twin fully. So, right, so usually we do those proof of value on subsets of network, a DMA, and so on and so forth. And so just to make sure that we understand the challenges, the values, and so on. And that's it. Sorry, I kept you for another couple of minutes beyond the bell, but that is it. That is everything that I wanted to share with you, and I'll give the mic back to our host, Alex.
Yeah, thank you very much, David and Tahseen. I think this concludes our presentation. We do hope that it was of value, and feel free to contact any of us for more information. And thank you very much. Thank you.